Hello, my name is Maximo Gomez, and this is the physics to my mimic. So first I wanted to find the potential energy of my mimic, which is half times the k constant times x squared. In order to find the k constant, I need to use the Hooke's law. In order to use the Hooke's law, I need to make the k constant equal force over x, which is the displacement of the spring that is either being stretched or compressed. In order to find the force, I needed to use mass times gravity. The mass was pretty small for my mimic, and then times the gravity, it gave me an outcome of negative 2.77 times 10 to the negative second newtons. And then for my x, I needed to do initial length minus terminal length, which was an outcome of negative 0.07 meters. And that after getting both of those numbers and plugging them into the k constant equation of force over x, I came up with the answer of 3.96 times 10 to the negative second newtons per meter. That's because both negatives canceled out at the end. After that, I can use the k constant to find the potential energy. By plugging that in, I get an answer of 1.94 times 10 to the negative fourth joules. After that, I am able to find the kinetic energy, of which the equation is half times mass times velocity squared. In order to find the velocity, first I had to do final displacement minus initial displacement, and final time versus initial time, and that gave me an answer of 2.83 meters per second. And then after finding the velocity, I could find the kinetic energy, which gave me around about a 1.13 times 10 to the negative second newtons per meter. That was after multiplying half times mass times velocity. After that, I was able to do the thrust force. The thrust force was mass times velocity of the ending minus mass times velocity of the initial, and times over the final time and initial time, and that gave me an answer of 0.025 newtons.